Good morning everyone, I am Mr. Ish. Thank you for joining me for this video. This is an optional video. We're looking here at the law of sines. You know, for any triangle, if you do this specific ratio, A over sine A is equal to B over sine angle B is equal to C over sine angle C. This represents the law of sines. The lowercase letters here indicate the length of sides. The capitalized letters here indicate angles. This is angle A, opposing it is side A. If this is angle B, opposing that is side B, and that's angle C, opposing that is little side C. This law of sines helps you determine a missing value. If supposedly you have two sides and one angle, based on how the orientation is, you can use this. If you have two angles on one side, you can use this formula as well. Based on which of those knowns you have, based on the orientation of the triangle, you can utilize this to find that fourth missing unknown. Basically, the formula really boils down to something like this. If you know three of these, you can find the fourth. The application of this specific law of sines is not difficult by any means, and I can show you, but in this video I want to just focus, after this specific example that we'll do, which will require a calculator, I want to focus on how this formula can be derived. It's a good useful exercise for pre-calculus students, geometry students, and trigonometry students. If you have a triangle which is represented in the following way, these are my angles. I have this angle to be equal to 70 degrees, and I need to find this side A, and I know this right here happens to be 50 degrees, and it opposes a certain side B. How can we do it? Well, we use the law of sines. We have two angles and one side, but based on the orientation, everything works out with regards to a good ratio. If supposedly you had angle C, but you didn't have angle B, then it would be difficult. You'd have to use the law of cosines. But you see here we have this and we have its side. We have this angle and we don't have that. So everything works out here with regards to this aspect right here. That's why I was saying it depends on the orientation and the actual knowns, what they orient with. You need to have that good orientation to develop this proportion and the ratio. You're going to do sine of angle A. And remember, you can do the angles on the top and the sides on the bottom, or you can do the sides on the top and the angles on the bottom. It doesn't matter. You can do sine of 70, which is angle A, divided by its corresponding side, is equal to sine of angle B, which is 50 degrees, divided by its corresponding length, which is 5. And you just have to run this through the calculator. Cross multiply and solve for A. You'll do 5 times 70 sine, and then you divide that by 50 sine, and you'll get a value 6.13, and it makes sense. Here A is equal to 6.13. What are the units are? A larger angle will oppose a larger side, a smaller angle will oppose a smaller side. Here this is larger angle, therefore it should be a value larger than 5, which it is. 6.13 is our answer. So this is the application with regards to the law of sines, but let's focus now in the remainder of this video at the derivation procedure of this specific law of sines, and you will enjoy it. It's not hard by any means, it's a very interesting one. Draw a triangle exactly like how I have, and identify the angles ABC and the corresponding sides A, B, and C. Remember, each side opposes its corresponding angle. Alright, now what you can do is draw a perpendicular line and create this large triangle into two small right triangles. Focus over here on this and focus over here on this, and on the trigonometric definitions of various angles. If you want to call this supposedly angle theta, and you want to call this angle theta with regards to sine A over here, right? If you did sine of angle A with regards to this theta, the definition is what? It's always opposite over hypotenuse. Isn't the definition of sine opposite over hypotenuse? Here opposite just happens to be a side whose length is h, height, divided by hypotenuse, which happens to be b, a length of the side opposing angle B. Now look at this angle right here and do its sine. Sine of this angle B with regards to its orientation, this theta, you have opposite over hypotenuse, which is h over A. In each instance, solve for h. Here h is equal to B sine angle A. You're just cross multiplying here. In this instance, h is equal to A sine angle B. We have that. We know h is equal to that and this is equal to that, therefore they're both equal to each other, and you can write that relationship down. A sine angle B is equal to B sine angle A. We've gotten that relationship out and it'll be very helpful. Now what we do is draw another triangle and evaluate another series of relationships. What we will do this time is we'll focus on C, and we'll call this A, we'll call this B. Again, I've drawn a perpendicular line and split everything here into two right triangles. Opposing this angle C is a side C, opposing this angle A is a side A, opposing that angle B is a side B, and we have this length or the height H. With regards to this angle, we can call that theta or sine C, it doesn't matter. With regards to this angle, you could call it C or theta. How about we just do sine of angle C is equal to opposite over hypotenuse. Here, hypotenuse ends up being the measurement of A. With regards to this right here, sine of angle A, again we use the definition of sine in terms of trigonometry, opposite over hypotenuse, H over C, and each instance you solve for H. H here is equal to A sine C, H here is equal to C sine angle A. And we can write this relationship here again because they equal each other. We'd have A sine angle C is equal to C sine angle A. Now that relationship right there, the two relationship equations we have will take us all the way through to finish, and I'll show you how. Now for the actual derivation from these two relationships, it's not hard. Take the very first one. You have A sine angle B is equal to B sine angle A. What you need to do is just cross divide. Bring each side with its corresponding angle, or bring each angle with its corresponding side. It doesn't matter which way you do it. Here you'll get sine A divided by A. Look at this relationship right here. You can cross divide. You'll have a sine C, bring the side, and you have a sine angle A and bring its side. We have this relationship over here. If sine A over A is equal to this and sine A over A is equal to this, by the transitive property, all of this must be equal to B as well. If 1 is equal to 2, 2 is equal to 3, then 1 is equal to 3. You know that property. So you can write it all out as sine A over A is equal to sine B over B, which is equal to sine C over C. And this is it. You could have done it the other way, where you're putting the sides on the top and the angles and you're cross dividing them, and you would end up with this orientation, but it's fine. Remember, for the law of sines, you must know at least 3 items to find that fourth. So you can do a clean ratio and proportion. Well, that's it for this video. Thank you for watching. Have a nice day.